Okay, class, welcome back. In the last sessions, we learned how to define class and create objects from the class. And we also learned how to reference member variables and invoke member functions in the class. But we haven't yet really talked about the advantage of using class and objects. So why do we have to use class and objects, and why object-oriented programming is so popular these days? We will answer these questions in these sessions. So let's begin. The class is full-fledged type, just like other types such as int and double. You can declare the variables of class type, and function can have class types of parameters. You can use class type of parameter as call by values and call by reference. And function can also return the value of class type. So you can use class type like any other types. And then why we use class? What benefits it gives to us? One of the key concepts in object-oriented programming is encapsulations. As shown in this diagram, encapsulation is about binding data and operations that manipulate the data together in single units. We can achieve this with class. We can consider member variables of the class as data and member functions as operations. And by binding member variables and member functions that manipulate the member variables in one class, we can achieve encapsulations. So these encapsulations is possible because of concepts of class and objects in object-oriented programming. Then why do we care about the encapsulations? The answer for this is that encapsulations gives some benefit to us, shown here. The first benefit is information hiding. We can make member variables private to the class. This means that the member variables or data can only be referenced inside the class, not from outside of the class. This will hide the informations or data from programmer who uses the class. That is the information hiding. The second benefit of using encapsulation is abstractions. Abstraction is a mechanism of exposing only the interface and hides the implementation details from the programmers who uses the class. We will talk about the interface in later slides. So such information hiding and abstractions prevent unnecessary access of the data and invalid modification of the data, which improves the reliability and maintainability of the program. Then how can we make the member variable private to the class for information hiding? The good design of the class is to set data, the member variable, as private, and operations such as member functions, which manipulate the data, to publics. By doing this, you can hide informations, the data, and able to validate the correct uses of data inside the member functions. So let me explain this with example. Okay, the example is, let me explain these concepts using this example. So if we look at the definitions of day of year class, which we used in the previous session for studying how to define class syntactically in C++, this class is syntactically correct, but it neither hides data, which is months and day, nor operations. What I mean by this is that if you look at this example, day of year class has two member variables, months and day, and we use day of year class here. We first create object of this class using these statements, and we use and then we set the member variables by using dot operator like this. Today is an object of this day of year class, and we are setting the months member variable of this today object using a dot operators. And we also set the member variable day using a dot operator here as well. So as you can see here, we are directly accessing and modifying the member variables in these today objects. So we are directly accessing this month and day member variable using dot operators. And we finally call the member function output to print these 2 months and day value. And the definition of this output function is shown here. There are a few problems in this class design. First, to use this day of year class, the programmer must know that there are 2 member variables, month and day. They must know these informations, which violates the principles of encapsulations because it does not hide informations. The information hiding we just talked about in the previous slides. And another problem is that programmer can directly access and modify the member variables using a dot operator like this. This is bad because programmer may mistakenly set incorrect values to these member variables. And moreover, programmers need to set member variable months and day to make the output functions operate correctly. So if they do not set these month values using this dot operator, this output function will not work correctly because this function depends on this month's member variables value and the day. So programmer must also know the implementations of output these functions. They must understand this implementation detail and set the month and day member variable accordingly. So this class definition is syntactically correct, but it's not designed based on the best practice. It does not follow the concepts of encapsulations, so it does not provide information hiding because these member variables are publics. So programmer can access this member variable directly using this dot operator. And it does not abstract operations of these objects. Programmer must know this implementation detail of these output functions to use this day of year class in correct way. So this is a bad designs of class. So let's fix this class. So first of all, there are something called private and public shown here. They indicate the visibilities of member variables and member functions. All the items below private are said to be private, and this means that they are accessible only inside the class. So they can only be referenced in the member functions of the class. Here, month and day, member variables are private. So previously, directly accessing them from outside of the class was possible using dot operators. So previously, this was possible because month and day was public, but now it is impossible because month and day are private. They cannot be directly accessed by the programmers or outside from the class. So now these two are not allowed syntactically. On the other hand, the items under public visibilities here can be referenced from outside of the class. So here, input and output are member functions and they are public. So this is allowed because output member function is public. So it can be directly accessed by the programmers or from the outside of the class. So can you see the differences now? We put all data, the member variables, private. So now programmer cannot directly access the member variables or data. This hides the details implementations of data, and by doing it, we can prevent programmers from setting invalid values to these member variables. And to access member variables, these private member variables, programmers must now use member functions, whether inputs or outputs. In the inside of these member functions, you can validate the input and set member variables only if input is valid. So by doing that way, you can prevent setting incorrect value to these member variables. So this is how you design the class. Normally, good programming practice requires that all member variables to be private, and that typically most member functions are to be public. But sometimes you may implement member functions which are only used inside of the class. So if you are sure if these functions are only for the member functions in the class, you should set private visibility for these member functions. So I have analyzed Android apps and programs running on a blockchain platforms quite a lot. And I found a lot of vulnerable Android apps and blockchain programs because programmers accidentally set public visibility to the sensitive functions. So you have to be careful when you are setting the function visibility because they may lead to some security issues. You can have any number of public and private specifier in the class definitions in any order. So as you can see here, you can put all the public items first and then put private items. And reverse is also possible. You can put private item first and then put public items. Or you can even mix private and public items shown in here. There's no universal agreements about whether the public members first or the private member first or mix them. It's just your choice. But in the textbook, it is recommended typically we place the public first. But it is not enforced by the C++ compiler. It's just your choice. So let's look at this demo code quickly. Okay. Let me create this demo code. Okay, so this is a demo code using a private and public items. So as you can see here, we have a class definitions. It has a public two member functions, output and assign. And then it has a two member variable, which is a private. And as I explained in the previous sessions, we only put the function declarations inside of these class definitions and put extra function definition in different location outside of these class definitions. So we put the function definition here with scope resolution operator and specify class name, telling C++ compiler that this output function belonging to this class. And same for this assign member function as well. This output function just prints the member variable month and day, and this assign member function sets the member variable month and day. And here we are using this pointer. We learned this pointer in previous slides because this member variable has the same name with a parameter name. And inside of the main function, we first declare the class. We create the objects. First day, which is objects of this day of year class. And it calls the assign member function to set member variable months to 5 and 11 today, and then prints it. So if I compile this program, it prints 5/11 because I set month 5 and day 11. And if I call output here, we put month, which is 5, slash print day, which is 11. So this is expected outcome of this program. But if I comment out this one, and the previous example, I set month and day using these public member functions. But in this time, I am directly accessing this member variable month and day using dot operator and set month to 5 and set 11 to day. Let's compile this code. As you can see here, compiler throws error, and error message is saying that month is a private member and day is a private member. And as you can see here, month and day are the private member variables. And because month and day are private, it cannot access from outside of the class. So programmer cannot directly access month and day using these dot operators. So that's how private visibility works. By doing this, we can hide this data from outside of the class. This is something called information hiding we learned in previous slides. Okay, so let's go back to the slides. Okay, so by now you understand that you should always make all member variables in a class private. But you may need to the value stored in the member variables, or you may need to modify the values stored in the member variables from outside of the class. And because we cannot directly access private member variable from outside of the class, we just saw this through the demo code. For that, I already explained that we should use public member functions for accessing member variables, accessing private member variable from the outside of the class. And if the member functions are for reading the values of private member variables, we call them accessor. If the member functions are for updating the values of private member variables, we call them mutator. So both accessor and mutator are public member functions of the class. And normally we include the word get, as shown here, as shown here, get for accessor functions, and word set for mutator functions like this. So get month is an accessor, which is a public member functions, and this function is for reading this month member variable and return this value of this month member variable to the function caller. And the accessor functions should return something, because the purpose of this accessor function is to obtain values of private member variables. So that's the concepts of accessor and mutator. And Let's talk about const. We learned constant variable in week 2. We learned that const variable can be initialized only once and its values cannot be changed. We can also make member functions const. So like this. If you put const keyword at the end of member function declarations, these member functions becomes constant member functions. The constant member functions cannot change the data in the class. The data is member variable, so it cannot change the values of member variables in the class. So typically we make accessor functions. We learned accessor in previous slides. So we typically make accessor function as const member functions because the purpose of accessor function is to read the data and not modifications. So by doing this, we can avoid accidentally changes to data from accessor functions. And you must be careful that const member functions can be called by any type of objects, but non-const functions can be called by non-const object only. Let's see demo code for these concepts. Okay, let me compile this program first. If I run it. Okay, if you look at this source code, there is a class definitions. Class name is CPE. And it has a public member function, get num of students, and set num of students. These two are member functions, and it has a member variable student number here. And this is a constructor. We haven't learned constructor yet. We will learn constructor next week, so don't worry about this concept. For now, this is not scope of the midterm exam, so you don't need to worry about constructor at this point. But if you look at this, get number of students member functions is declared with const. So this is a const member functions, and this is non-const member functions. So this const member function just returns the value of student number member variable, which is this one. And this set number of students functions sets the student number variables to this parameter value num. And inside of this main functions, we create one object of class CPE with a const keyword and another object with class CPE without const. So these 1 and 2 are both object of CPE class, but 1 is a constant objects and 2 is non-constant objects. So here we are printing the student number values in object 1 and 2 using a get number of students member functions. Note that this get number of students function is a constant member functions. And because we set the student number to 0 here, it prints that D1 is first object, D2 is the second object, 2, 1, 2. The student number of the objects is 0, and the student number of object 2, which is D1, is 0 as well. So it's printing this one. But as you can see here, 1 is a const objects, and 2 is non-const objects. So we can call the const member functions with both const objects and non-const objects. And let me change the source code. Now we are calling set number of students, which is a non-const member functions using one const objects and non-const object here. So if I compile this program, as you can see here, the compiler arrow shows here. It says that this arguments to member functions set number of students has type const CPE, but function is not marked CPE. So line 24 here. So as you can see here, this one object is const type of objects. We cannot call non-const member functions using const type of objects. So that's what this compiler arrows mean. You cannot do this. We can only call the non-const member functions with non-const objects. So that is the difference between const member functions and non-const member functions callings. Okay, so let's go back to the slides. Okay, so we talk about the const member functions. Let's study more about the constants here. If you look at this example, there are 3 const keywords, and they are all cause different consequences. The first const, this one, make the value that the pointer variable points to become constants. And the second constant here makes the pointer itself constants. And the third one here makes the member function const, which we just talked about using demo code. So don't be confused about this. Depending on the location of the const keyword, it causes a different result. So let's look at the demo code for this one as well. So this one. Let me compile this program first. Let's see that. So here we have a 2 type of variable, number 7 and 8, which set to 7 and 8 respectively. And look at here, we put const here and we put const here for address const variable and const address variable. And we both pass the address of the number 7 variable. And if we print the number 7 address, the address of number 7, I mean the value is 7, obviously. And the address of addr constants, this one, and const address is same as well. So as you can see here, these two pointer points to the same memory address, which should be address of this number 7 variable. And here, address const. We are setting the address of number 8 variables to this const address. And if we print it, number 8 is obviously 8. And now const address changes to this address, which is a address of this number 8 variable. So as you can see here, even though this const address here is declared as constants, we are able to change the address change the value of this const address. And same for this one, addr underbar const, which is this one, is currently holding this address of this number 7 variable. And if we do this and set 77, number 7 is now 77. So even though this address const is declared with const, we are able to change the value that this pointer points to 77. So we change 7 to 77. So we can change it even though these two variables are const. However, we cannot do this. For example, if I compile this program now, it's compiler error because of this line. So address const is this one. We cannot do this because we said that this const makes the pointer itself const, so we cannot change the value of const. So that is the reason why it's compiler source error. And same for this one. All right. This const address is this one. So this one, this const makes the value that this pointer variable points to makes constant. So you cannot change the value that this pointer points to using this asterisk operator 88. So this should lead to compiler error because of this const keyword. So let me compile this program. Let's see the output. As expected, compiler throws error message in 26th line because of this. Because of this const keyword, we cannot change the value of this pointer points to. This is incorrect. So depending on the place location of this const keyword, different results are derived. So you have to be careful about this. Okay, so let's go back to the slides. So be careful, this const keyword, depending on the location of this const, is different. It has a different meaning. Here we saw this demo code. Okay, so far the members from one object cannot be accessed by other objects. So for example, here we have a CPE class, which consists of one member variable bonds. And here we create two different objects from CPE object class and setting the member variable of bonds using dot operator. This is possible because this member variable is public. And as you can see here, even though they both generate from CPE class, if you look at this, even though this object 1 and object 2 are generated from this CPE class, these two objects are completely different ones. So they are not equal. And because obj1 and obj2 is different, obj1.months and obj2months are also different. So if you print the address of this one and this one, they should be different. And even obj1 and obj2, the object of these two objects, also different. So with this CPE class, it is impossible to share the data between these two objects, different objects. But sometimes you want to have one member variable in the class that is shared by all the objects of the class. You might want that in some situations. So like this one. You might want to share data between two different objects. For this, we use static members. So we can make both members variables and member functions as static. So we can make member variables and member functions as a static. So let's first look at static member variable first. So in order to make the static member variable, you indicate static keywords at the start of the declarations. So if you make the member variable static, all objects of class share one copy. So if you look at this example, this is declarations of member variable, but because we put static here, it becomes the static member variables. And these static member variables are shared by all objects of class. And every static variable must be initialized outside of the class definitions. So you should not should the C++ compiler enforce you to not initialize this static member variable inside of these class definitions. So you cannot do that. So here in this example, we did not initialize static variable inside of these class definitions. As you can see here, static member variable turn is initialized outside of the class definitions here. And unlike the accessing ordinary member variables, we do not use dot operators. Instead, we use class name and scope resolutions operator, which is a double colon like this. And moreover, a static variable cannot be initialized more than once. So if you initialize static variable once like this, the next line is an error, compiler error, because it cannot be initialized again. So any objects created using this server class share this turn static member variables. So now let's talk about the member functions. Member function can also be static. The member function can be static if we indicate the static keywords in the member function declarations. And we only put static keywords in member function declarations, not in the member function definitions. And I will explain this syntactic with concrete example in the next slide. But let's first talk about the characteristic of static member functions. The static member functions can only access the static members. Okay, so the static member functions can only access the static member variables. It cannot access non-static member variables. So shown here. And inside of the static member functions, non-static member functions cannot be called. This is because static member functions does not know the class instance. It does not have this pointer that we learned in previous slides. And static member functions can be called in the normal way using an objects or object and dot operators. But it is more common to call a static member function using the class name and scope resolution operator like this. So if we assume that this getTurn is a static member functions, you can call this static member function using this class name followed by this scope resolution operators. And you can also call this static member function using these dot operators and put the objects here. These two result same, but typically we use a class name and the scope resolution operator when we are calling the static functions. So let me explain static members with concrete example. So if you look at this code, we have class definitions from here to here. The class name is a server. It has public items here and private items here. And as you can see here, this is a constructor. You don't need to know about this at this point. And we have two static member functions, getTurn and still open here because it is declared with static keywords. And it has a one member function, which is a non-static member function, serve one here. And it has a non-static member variable name and three static member variables here. And note that you did not initialize the static member variable here inside of this class definitions. And instead, you initialize static member variable outside of these class definitions here using a class name and the scope resolution operators. So you turn static member variable to 0, and you initialize last serve static member variable to 0, and you set now open static member variables to true. So this is how you initialize static member variables. And as I said already, that this static member variable can only be initialized once. So if you initialize static member variable like this, you cannot re-initialize them, okay? That will lead to compiler error. And here you put the function definitions for these get turn static member functions and still open member functions. Get turn and still opens are static member functions here because we put static keywords here. But note that in the function declaration, we put the static keywords, but in the function definitions, we did not put the static keywords. So you only put the static keyword in function declarations, not in the function definitions. So you have to remember that. And inside of these static member functions, you can only access static members. So this get turn static member functions increase the turn member variable by 1 and returns it. Turn should be a static member variable. As you can see here, turn is a static member variable. If this turn is non-static member variable, this will lead to compiler error. And as you can see here, now open is also static variables. So this is possible. If now open is non-static member variable, this line also should lead to the compiler error. And when you call static member function, you use a class name and scope resolution operators, like this example. And as you can see here, serve1 is a non-static member function. So we call this serve1 function using a dot operator, putting the object here. S1 is a object of this server class. So this is how you declare the static member function and static member variables, and initialize static member variables, and define static member functions like this, and use static member functions like this. Okay, so this is the output of this example code. So let's look at more about the static member using our demo code here. Okay, so let me compile this program first. So this is the output of the program 00. Let's see why this prints 00. So if you look at this code, this is class definitions. Class name is obj. It has 4 public items and 2 private items. One is private member variables and one is static member variables. And we have 2 non-static public member functions and 1 public static member functions and 1 public static member variables here. And we initialize static member variables outside from the class definition. So count and count2 are static member variables. Count2 is private visibility, count is public visibility. And when we are initializing static member variable, we use a class name and a scope resolution operator like this. And here we define member function print info and member function print count, which is static member functions. And note that there's no static keywords in function definitions. You only put the static keywords in function declarations. And set name is also public member functions. It just sets the name member variable, which is a private member variable. And in the main, we create 2 objects for class obj. obj1.setName, obj1, obj2.setName. So we call this setName member functions, which is a non-static member function to set this name member variable for this obj1 and obj2. And then we print by calling these static member functions. Print count is a static member functions. And this print count, and because count is 0, this program produces 0 and 0 output here. Here. Okay, so note that this is a static member function. So instead of using this object and dot operator, we can also call this static member function using this class name and scope resolution operator. So if I compile this again, if I run it, now as you can see here, it prints 0 3 times because of this one. So this is syntactically correct. And do you think we can do this? Set name is let's see, set name is a non-static member functions. So if I compile this program, what is the file name? So compiler throws error message in 43 line here because I'm calling non-static member function using this class name and scope resolution operators. You cannot do this. You can only use class name and scope resolution operator with static member functions, not for non-static member functions. So this is syntactically incorrect. And if I compile this program, this print 0011 because 00 is here. And now I set the count static member variable to 1 here using this class name and scoop operators, and print the count number again. And because I set 1 here, it's printing 1, 1. So this is possible because count is static member variables. So we can access this count using a class name and a scoop resolution operators. And because this is public static member variables, we can directly access this one as well. So this is not possible. This is not possible. This should throw compiler error. This should lead to the compiler error. So if I this, as you can see here, compiler throws error message that count2 is a private member variable of obj class. So count2 is private. So even though this count2 is a static member variable, because it is private, it cannot directly access it through like this way. So this is not possible. And let me change this one. This to this. So this print counter is a static member functions, and name is a non-static member function. I mean, non-static member variable. So this also should lead to the compiler error. Let's see the compiler actually throws the error message. As you can see here, compiler throws error message on 25 line here, this one. That's because static member functions can only access static member variable. It cannot access non-static member variable. And because name is a non-static member variable, compiler throws error message here. And one more thing. I change set name member functions, which is a non-static, to this one. Now specify class name. This one also should throws leads to the compiler error. As you can see here, the compiler says on declaration identifier name. Compiler cannot find name because name is a static member variables of this object obj class, and because we did not specify the class name like this one, we did not tell this set name function belonging to this class, so compiler cannot find this name member variables. So you have to specify class name when you are defining member functions. Okay, so let's go back to the slides. Okay, so now let's talk about the interface. In object-oriented programming, OOP, it is crucial to separate interface and the implementation of the class. The principles of encapsulations we learned in previous slides is about designing classes so that the programmer who uses the class need not know the detailed implementation of the class. So that is the principle of encapsulations. The programmer who uses the class need only know the rules for how to use the class. And we call this rule as an interface. So you should design the class so that the interface of the class should be all programmer needed to know in order to use your class. And the interface consists of two things. The declarations of public member functions and associated comments. So this interface should be open to programmers. And the implementation, which consists of private members and the definitions of public and private member functions, should be hidden to programmers. So what this means is that the detailed implementation should be hidden to the programmers who uses your class, and you should only open the interface to this to the programmers. So you should clearly separate this interface and detailed implementations, because it makes more reliable and maintainable program. And more importantly, programmers don't actually care about the detailed implementations. So for example, we learned string class before, and I'm sure you have been using string class for your weekly assignment. So string class itself has many member functions. Among them, this size and length is the member function of the string class. And I think you have used one of these function for your weekly assignments before. And as you can see here, this is an interface. It tells you about the member functions. Both function returns the length of the string. By reading this interface, you know what this function does, even you do not know the detailed implementation of these functions. So, and you can use this function like this. You can use length functions like this. I'm sure you used length functions for your weekly assignments. You use length functions, but do you know how this function is implemented? And do you know what member variables uses in these length member functions? No, because they are hidden. And have you ever saw the implementation of these length member functions before? I don't think so. So like this, you should design the class so that the programmer can use your class like a string class with just knowing the interface. So we use these length functions by just reading this interface, not actually care about the detailed implementation of these length functions. I don't care about it. I just care about this interface before using these functions. Okay, so in this week, we also learned structure. And technically, structures and classes are same in C++. in C, structure could not have member functions, but in C++, structure can also have a member function like a class. So technically, class and structures are the same. But there's one difference. The default visibility for structure is public, whereas default visibility for class is private. So that is the difference. So if you do not specify public or private visibility, the items become public in structure and private in class. Okay, so let's finally talk about the object-oriented programming, OOP paradigm. The C++ is OOP. Before, you have been using C, which is procedure programming paradigm. In C, functions are important. The programs are divided into small part of the functions in C. So in C, program is based on algorithm center. In C++, the OOP paradigm, data is more important than functions, and program is divided into objects, not functions. And algorithm also exist in OOP, but their focus is on their data. The algorithm for operating data in objects. So in OOP, we define objects and how they interact. So that's a big difference between procedure program paradigm such as a C and object-oriented programming paradigm, which is C++ and Java. Okay, that's it for these sessions. See you in the next sessions.